This is lesson 3.3, starting with page 18 in your notes. You've been studying systems of equations and how to solve them, so how to solve by substitution and elimination and to solve by graphing. Now we're going to focus on systems of inequalities. Remember, an inequality is something that has a greater than or a less than symbol. When you have a system, remember this means that you have two or more of them. So this is what we're going to be looking at, two or more inequalities, and how do we find the solution points. So even though you would do equations algebraically or graphically, we're going to solve inequalities only graphically. And let's think about why this might be. Remember that when you have an equation, you will have a single value or ordered pair that is your solution point. And this can be the solution point where two lines or two equations intersect at one point. But an inequality has many solution points. And when we try to solve two inequalities, we're trying to find many solution points that work for both of them. And algebraically, this can be quite a lot. So we're just going to focus on the graphical side. All right, when you have a system of inequalities, you've actually already seen a little bit of this before. You want to make sure that you have each inequality already set up with a y equals for something, which we have here in our first one. Each one has a y equals. We're going to graph the boundary lines for them, and then we're going to see where they overlap. So for our first one here in yellow, y is less than or equal to x. This means we're intersecting at the 0 marker, and we're going up 1 over 1. And this has a solid line because it's equal to. And it says that y is less than x. So for this yellow one, we will shade this area here. Now for our blue one, it says 3x minus 1, so we'll start at negative 1. And we have a slope of 3, 1, 2, 3 over 1, 1, 2, 3 over 1. This one is also a solid line. And this one, the blue, says that it's greater than, so we would shade above the green line, or the blue line here. Now, notice that the yellow shading goes with the first equation, the blue shading goes with the second one. The answer is the overlap area, or the area where you see both blue and yellow, in this case green. So this area here, this is actually the solution to your inequality, okay? Not the other two sides. In fact, we could erase the blue and the yellow, and your final answer would just be this. This is where both of them overlap. Okay, so that is your final answer. Take a look at another example. This one we actually need to solve for our y's. So we need to add x to both sides here. So we get y is greater than x minus 1. That will go ahead, that will be our first equation. And then for our second equation, we have to subtract an x. So we get y is greater than or equal to negative x plus 3. And this will be our second equation. All right, so for the yellow, or the first equation, we start at negative 1, slope of 1. Notice that this one, this time, is a dotted line. And it says that it's greater than, so we will shade up above. For our second equation, we start at positive 3 and a slope of negative 1. And this one has a solid boundary line because of the equal sign, and it also says that it is shaded above. So above this one here. Now again, the overlap area is the area that would be our answer. So this area here, this would be the answer. This is not part and this is not part. Only that part where they overlap is our final answer. So if you're doing this on your paper with pens or pencils, you would want to make sure that you shade this section really, really dark and even erase those other sides over there as part of your work. Okay, that's the only thing that should be left. Now here's a fun one. This one gets a little different because we have an absolute value sign in here. So for our very first one, y is greater than or equal to 3. Now remember 3, that's the y-intercept, and there is no slopes. There's no up over. It's simply straight across, and it's equal to, so we have a solid line. And then we'll shade above, because it's greater than. And then our second line here, remember this is an absolute value, so that's the V shape. Remember on the outside, this means up 5. And remember that this piece here means left 2. Remember, it's always opposites when it's inside the absolute value, so it's the other direction. And then this little guy here, remember this means reflect. Reflect over the x-axis. So I'm just going to draw a quick sketch of him on the side so we understand what we're doing here. We're going to go up 5, 1, 2, 3, 4, 5. We're going to go left 2. But instead of pointing upwards like we normally do, he's going to face downwards because he's reflected over the x line. So that's what we need to graph on here. 1, 2, 3, 4, 5 over 2 and facing downwards. And whoops, we need to make sure that we make him 1, 2, 3, 4, 5, 1, 2. He needs to be a dotted line. Because he does not have the equals bar. And then it also says that he is shaded above. So everything that is above the absolute value. So notice what this gives us for an overlap. This is kind of funky. The overlap area is this green part, so we don't include this wing or this wing, and also we're not going to include that little triangle. It's above the y equals 3 line, but it is not above the absolute value. So that little triangle is going to get left out. Our final answer is going to have just that shaded. Okay, so we can erase the blue and erase the yellow, and there you go. That's your final answer. Now, one more thing we need to look at is, let's say I give you a bunch of graphs and you're going to tell me which points would work as solutions. Remember, that means where are they true. So I'm going to zoom out a little bit here so we can see more of our page. So tell which of the inequalities below, graphs A, B, or C, would have the following points as solutions. So what I'm going to have to do is we're going to look at A and B together, and then we'll look at C separately because we can't see C here at the bottom. Can't see him at the whole time that we can see the other two, but that's okay. So for 0, 0, is that true for graph A? Yes, it is, because it's in the shaded area, so it works for A. Does it work for B? Yep, it does. And then -2, -2. Yep, right here, that would work for A. For B, no, it would not, because here's -2, -2. That does not fall in the shaded area. 1, 0. This would be 1, 0, so yes for A. 1, 0, it falls right on the line, and it's a solid line, so it also counts for B. If it had been a dotted line and it fell on the line, we would say no. 8, 0, so 6, 7, here's an example. Here's 8, 0, falls on the line, but it's a dotted line, so we can't count it. And even though we can't see 8, 0, it's off the graph, we know that the graph's not going to hit for B, so neither one of those. 1, 3, so right about here, so that works for A. And 1, 3 also works for B. Oh, this is a repeat one here, so 1, A and B again. And then 0, 4, that'd be up here, so that would work for B. 0, 4 for A would fall right on the line, so not that one. negative 4 comma 6, again right on the line, so not that one. Negative 4 comma 6 would be right here. Doesn't look like our graph would reach it in time, so not that one. 0, 8, yep, that would be B. 0, 8 here, nope, not A. 2, 4, nope, not A. And 2, 4 fell right inside the line there. Okay, so then if I wanted to go back and wanted to see which ones worked for C, let's take a look here. C is going through 1 and 1 right here. So 2 comma 4 would work for C. 0 comma 8 would be up off this graph. That would also work for C. 1 comma 3, yep. 8 comma 0 would be off on the side, so that one would work for C. We have points like 0, 0 and negative 2, 2. 0, 0 will not work. Negative 2, 2 will not work. That's down here. We have points like 1 comma 0. One comma 0 lands right here, and it's a solid line, so we'd say that one works. And then we have 0, 4, yes, that one will work, and negative 4C, no. So this one worked for none of them there. So there are your answers if you want to see, looking at your graphs and double checking on your notes, which points would work.